The network was routers and switches, and servers connected to switches. And we could walk into the data center, Carl could go into the closets, and he could see the network. He could reach out and touch it. It was painted teal, it had Cisco silk screened on it in white letters, and it was the good days of the network. It was obvious, like that was the network, and it was easy. But times changed, and they kind of like snuck up on Carl a little bit, and the network began to evolve. And the first hint that he saw of this were these guys that came into his environment. V-switches, virtual switches, and virtual machines.
That's DevNet's Hank Preston, an engineer and content developer for Cisco. In this episode of the Cisco Learning Network Podcast, Hank will walk you through the evolution of the network engineer's role in the industry, beginning with the interaction of physical appliances before virtualization. In addition, Hank will cover some programming and networking skills that are relevant today, and will also talk about the Open Systems Interconnection, or the OSI model, which is a 7-layer conceptual model that characterizes and standardizes the communication functions of a telecommunication or computing system. Hank recently spoke in a software-defined networking webinar hosted by the Cisco Learning Network, and begins by talking about some of the resources that are available to you through DevNet, which we'll link to in the description of this episode.
The point of the discussion and what we're going to go through here is just kind of what's going on in the networking space that's kind of impacting the skills we have to learn and kind of what qualifies as network today. My name is Hank Preston. I'm a Net DevOps Evangelist in Cisco DevNet, which is our developer program and organization. So if you're not familiar with DevNet, we offer API references, sample code, learning labs, sandboxes to test out and try out some of the different Cisco infrastructure, as well as hold events both at Cisco Live as well as kind of outside and regionally, talking about all of these great programmability topics. And we've had a long partnership here ongoing with Cisco Learning Network to kind of bring the message to all of you. So let's jump into our content for today. So topics to cover. I got kind of 4 bullet points we're going to run through here. We'll start out with a look back in history. The network engineer of old, or probably the network engineer of today for many of our cases. We'll kind of look at what the network engineer looked like, kind of what the network has done over time, and then we're going to transition into kind of the evolution of networking through the ages. I like to call it the 4 ages of networking, kind of starting way back when and bringing us all the way up to today in the programmable age. Cloud, we certainly can't ignore cloud and the impact of cloud and IT in general, but particularly for us in networking. So we'll talk about kind of what is the impact, what does cloud have on us, what are some of the challenges and the approaches and kind of some of the things that we have to recognize about dealing with the cloud and what that means. And then we'll end with a discussion about kind of what does today's network engineer look like? How do we get there? What skills are needed? In addition to all of the critical networking skills. Clearly, still understanding fundamentals of networking will be important to us kind of forever, but there's definitely some other pieces that we have to go through on that side. So, the network engineer of old, way back in the Stone Age, where did we come from? What did we do? Kind of what was important to us? And for this discussion, I want to introduce you to a friend of mine, Carl, the network engineer.
Hank gets to a slide in his presentation that has a middle-aged cartoon man in a suit frowning. This man is Carl, the network engineer. On the left side of Carl are a list of his programming skills, TCL, EEM, and expect scripts. And on the right side of Carl are a list of his networking skills, ranging from spanning tree to MPLS, or multi-protocol label switching.
Carl is a network engineer's network engineer. He's been doing this for a long time. He's been out there since the days before IP was the only real protocol of necessity to know on the network. And he's built himself a huge set of networking skills that have made him successful and really kind of popular among his peers. He's a go-to resource for asking questions. And he's also got a handful of programming skills that he's built up kind of over the years that relate to how he's addressed and done configuration and operations management and all of these pieces for the network. But it is all these networking skills that he has. Spanning tree, clearly a critical skill set that we all have to understand in the networking, and that's not going anywhere. Carl understands spanning tree like it's in his blood. It's the back of his hand. He knows all of the differences between spanning tree and rapid spanning tree and multiple instance. He can quote off all of the default values and then explain to you why maintaining the default is never a good idea. But not to be pigeonholed as a layer 2 only guy, he's also got all the routing protocols down. He can sit there and debate either side of the great OSPF versus EIGRP debate, right? Open, or do you go with kind of the proprietary routing protocol? And he's always really gentle with those new engineers that come in and ask, why can't we just use RIP? And explain, well, RIP is a great routing protocol to learn and understand the basics, not really practical for a production kind of enterprise-grade network. As applications and differentiated service have come onto the network, he picked up QoS and shaping and rate limiting and tagging and marking, got all that down. He's building networks across the internet securely with VPNs. But spanning tree continues to be one of these technologies he comes back to. I mean, his stories of the great spanning tree outage of 2008 are epic. He'll sit there wrapped in attention at the lunch table, describing how after 8 hours of the network being down, he was standing in the data center, right in front of that Catalyst 6500, and a sense of inspiration hit him, and he reached out like Radia Perlman herself was standing over his shoulder, disconnected that cable from the network and stopped that bridging loop, and brought everything back to health. I still get chills just thinking about that story as it goes through. The network moved from data only to voice, so voice over IP became a critical protocol and technology to learn about. And then along with voice came storage networking, so fiber channel, additional security policies. And did I mention how much spanning trees kind of impacted Carl's ability to be a network engineer today? And then with those, he's got the tickle scripts to be able to kind of tease the router and information that's out there and avoiding those 3 a.m. calls when a mistaken interface is shut down or something odd happens on the router. He's taking advantage of EEM, embedded event management, to kind of get a little bit of automation and self-healing into the network. And then definitely getting sick and tired of just copy and paste over and over again, leveraging expect scripts from some automation. So this is what Carl's skill set, and the network engineers that Carl works with, these are the skill sets that they've had for a long time. They've built them up, and they've suited them quite well kind of over as things have gone through. And this is because when Carl started, the network looked like this.
Hank moves next to a slide depicting a simple traditional network configuration. On the top, 2 dark blue rectangles placed side by side have the word router inside of them. Below those routers are 2 light blue rectangles, also next to each other, with the word switch inside of them. The routers are connected by the blue lines to the switches, and the switches are then connected by those blue lines to 3 smaller orange rectangles at the bottom that have the word server within them.
The network was routers and switches, and servers connected to switches. And we could walk into the data center, Carl could go into the closets, and he could see the network. He could reach out and touch it. It was painted teal, it had Cisco silk screened on it in white letters, and it was the good days of the network. It was obvious, like that was the network, and it was easy. But times changed, and they kind of like snuck up on Carl a little bit, and the network began to evolve. And the first hint that he saw of this were these guys that came into his environment. V switches, virtual switches, and virtual machines.
Below and connected to the server rectangles now emerge 2 additional rectangles on Hank's slide that have the word vSwitch inside of them. And then below and connected to those 2 vSwitch rectangles now appear 6 squares with the letters VM inside of them.
When Carl got word of these and he was talking with some of the server guys and the teams, and he's like, virtual switches? I mean, the network is a physical thing. I can see it. I can touch it. Switches aren't virtual. They're physical appliances that we can touch and see. And that's just software. Not to mention, nobody's ever going to put anything of importance or critical nature in a virtual machine, right? We need to keep that physical and hardware. And so when vSwitches came in, Carl and his team, he said, you know what? You server guys, why don't you just take care of that virtual switch? We'll focus on what's really important, that physical network, that physical router and switch, and we'll deal with there. You guys play with that software stuff. But over time, the vSwitch was joined by these guys, the blade switches.
Hank inserts 2 additional rectangles into the network diagram between the switch rectangles and the server rectangles. These 2 new purple additional rectangles, which now connect the switches and the server icons, are labeled blade switches. Blade switches deliver Blade server network services that extend from the Blade server edge to clients at the network edge. These purpose-built I/O solutions let you deploy a virtualized data center infrastructure and promote IT productivity.
these I/O modules that sometimes weren't even called switches, that showed up inside of blade server chassis from vendors like HP and Dell and IBM and Lenovo. Well, here's another case where these seemed a little bit more like switches, but Carl looked at them and they were purchased from compute vendors. They typically came out of the budget from the compute teams, and blade servers, those aren't really that important. You know what? Let's let the server guys deal with those. Heck, most of those times they're called I/O modules or other types of things. Nobody even really wanted to call them switches. We're not going to deal with those. We'll let the server guys take care of that as well. And it continued from there. And now we're starting to see these pieces where we've got LVRs and containers.
Connected to the VM icons are now 4 new smaller blue icons labeled LBR for Linux bridges. A Linux bridge is a device that separates 2 or more network segments within one logical network, like a single IP subnet. A bridge is typically between 2 separate groups of computers that talk with each other. Below these Linux bridges are even more smaller yellow rectangles, each labeled C for containers. A container is an isolated execution environment on a Linux host that behaves much like a full-featured Linux installation with its own users, file system, processes, and network stack.
Little Cs are containers that are having workloads inside of virtual machines connected to Linux bridges or LVRs. Now our workload is behind a virtual machine that's connected to a virtual switch, inside of a server that's behind a blade switch, and we're so far away from what the typical network that Carl was used to dealing with. And all of this happened so fast, and it snuck up on him without even realizing what was going on. But it didn't stop there. Then came the cloud and the cloud exchanges, and how do we connect our data centers and our networks to the cloud? And then all of the workloads that are in the cloud. We've got virtual machines and containers that don't connect to anything that we can actually remotely recognize as a typical network. Not to mention all of the as-a-service things, databases as a service, directory, function as a service. So much has changed in the network and connectivity and how it goes through. But I'm still not done. We've got load balancers and firewalls and IPSs and gateways and lions and tigers and bears. Oh my. I mean, the network over the last several years and fairly quickly has evolved from the days of when the network was routers and switches to this type of a picture. There is so much in scope for the network, and Carl finally and his team kind of made note, recognized that things were changing, that the network just wasn't there, and recognized that he had to dive into some of these other areas that weren't just the typical physical switch that was out there. But networking was still critical across the board. So that's a little concerning going through. How do we address a network that's this large and this disparate, things that we have to go through where there's not a patch cord to be seen? So let's take a moment and resettle ourselves back to something I absolutely know all of you on the call are recognize here, the OSI model of network.
On Hank's next slide, he displays a diagram showing the layers of the Open Systems Interconnection, or OSI model. On the bottom is the first layer, the physical layer. On top of that are the following layers in this order: data link, network, transport, session, presentation, and application. These are the 7 layers of the OSI model.
The 7 layers that we all memorize, from physical up through application. Choose your mnemonic device so that you can quote them out and have that definition. So when you recert or you take your certification exam, you can say, what is the network layer for? What is the presentation layer for? But if we're really honest with ourselves, we can break down the 7 layers of the OSI model into 3 layers. In the middle, right, we have the, oh yeah, we got this layer. Top of layer 2, layer 3, and layer 4.
Those are the data link, network, and transport layers.
When we're talking about MAC addresses, IP addresses, or TCP, UDP ports, we got that. That's core networking skills. Those are fundamentals that we all have. We can quote out subnets and subnet masking. We can do logic and XOR math to subnet appropriately for all those tests that are out there. But that's just a sliver of the OSI model that's out there. At the bottom, we have the black magic layer, right?
This black magic layer consists of half of the data link layer and the physical layer.
The physical layer, the connectivity. How do we actually transmit data over a copper cable or an optical fiber cable? What black magic is involved in getting 100 gigabit of traffic to flow over 2 wires? or take that single Cat5e cable and now start to send multi-gig traffic over it. Not to mention the elements of the data link layer that are below the MAC address, right? We all kind of know that they're there, but we focus on the MAC address. And then up at the top, we have the please God don't ask me about these layers.
This includes the session, presentation, and application layers at the top.
It even says application there in layer 7. And despite the fact we can probably quote the definition, many of us have kind of stopped at layer 4 and said, you know what, all that other stuff, that's application focused, we don't have to deal with that. Now, frankly, this approach, this concept of black magic, please don't ask me about this, and just that little sliver that we focused on in the past, we have to change our mindset. Today, with the advent of microservice applications that are leveraging REST APIs for connectivity, we have to understand the application and the presentation and the session layers so that we know how HTTP works and we can help troubleshoot it. We understand the authentication that goes beyond and how we get stateful communication between protocols. And then at the physical layer, as we start to get different speeds across the same wire, connectivity and all of those pieces go through, we really do have to have a solid understanding from layer 1 all the way to layer 7 to continue to be successful and strong network engineers in this programmable age as we go through.
To hear more from Hank Preston or to view the full webinar that this segment is from, be sure to visit the Cisco Learning Network at www.ciscolearningnetwork.com. You can also visit the link in the description, which will take you to more training videos hosted by the Cisco Learning Network that lay your foundation for software-defined networking. The Cisco Learning Network contains all kinds of resources to help you get started on your networking career, including additional training videos and study groups that allow you to connect with others trying to get started in their networking careers. Please subscribe to the Cisco Learning Network podcast and be sure to leave us a review on iTunes if you found this helpful. Thanks so much for listening.